past year NEET questions from the topic surface chemistry. We'll start with a question that has come in the year 2012. Which one of the following statements is incorrect about the enzyme catalysis? So we'll go through the options. Option A is saying that enzymes are mostly proteinous in nature. So most of these enzymes are actually proteins in nature. So that is a correct statement. Option B is saying that enzyme action is specific. So enzyme activity is very specific in nature. So for a particular biochemical reaction, only very selective enzymes can be used. It is largely attributed to the shape of the enzyme molecule. Option C is saying that enzymes are denatured by ultraviolet rays and at high temperature. So basically under conditions of high temperature or when we incident UV rays on the enzyme, the activity of the enzyme can be denatured. So this is also a correct statement. Option D is saying that enzymes are least reactive at optimum temperature. So this is incorrect. The idea of optimum temperature and the optimum pH value are basically the conditions under which the enzyme activity will be very high. So the incorrect statement is option D. Next we look at a question that has come in the year 2012. The protective power of lyophilic colloidal sol is expressed in terms of. So when we add a lyophilic colloid to a lyophobic colloid, the lyophilic colloid can stabilize the lyophobic colloid, and the protective power of the lyophilic colloid is expressed in terms of gold number. So gold number is basically the milligrams of the protective colloid which is just sufficient to prevent the coagulation of 10 ml of standard gold solution when 1 ml of 10% sodium chloride is added to it. So if you have 10 ml of the standard gold solution and we add 1 ml of 10% NaCl solution to it, because when we are adding electrolyte that will try to destabilize or coagulate the sol, and to prevent the coagulation we must add some amount of the protective colloid. We are measuring what is the amount of the protective colloid we are adding in terms of milligrams, and this is what is called as gold number. So the protective power is measured in terms of the gold number. So if the gold number value is lesser, that would mean that we require to add only small amount of the protective colloid to stabilize this. Means the protective power will be higher. So when the gold number is less, the protective power of the colloid will be higher. So the protective power is expressed in terms of the gold number. Correct answer is option B. Next we have a question related to the adsorption. If X is amount of adsorbate and M is the amount of adsorbent, then which of the following relations is not related to the adsorption process? So if we look at adsorption process, X by M will be measuring what is the extent of adsorption. It's basically the mass of the adsorbate divided by the mass of the adsorbent. Now the X by M value will depend upon temperature as well as pressure. So if you are looking at the adsorption of gases on the surface of a solid, what usually happens is if the temperature is maintained constant, then what we see is with increasing pressure the X by M value will initially increase and then it will reach the saturation value, but it will depend upon the pressure. Means if we maintain temperature constant, then X by M value will be a function of the pressure. If we maintain pressure to be constant, then X by M value will be depending upon the temperature. At high temperature, the extent of adsorption will be lesser, and the second one is also appropriate. Third is saying that for constant x by m, if you want to maintain the extent of adsorption constant, the pressure and temperature corresponding, they both will be related. So if we need to have the constant extent of adsorption, if we are maintaining high pressure, then that would mean generally if the temperature is maintained constant, high pressure will increase x by m value. If you want to maintain the x by m value constant, then accordingly the temperature also must be increased. Whereas at low pressure, they can maintain the same value of x by m with low temperature. So if you want to maintain the x by m value to be constant, then the corresponding pressure and temperature values will be having a correlation. The last one, x by m will be equal to pressure into temperature. This is in fact the incorrect correlation. Why? Because if we want to maintain the x by m value to be a constant, then that would mean the pressure and temperature, they would have a proportional relation. So if the pressure is high, then temperature will be high. Pressure is low, the temperature will be low. So if we have x by m is equal to P into T, that would mean that if you are looking for say for example P value, it will be 1 by T into x by m. So the temperature will go to the other side, denominator. So here as per the given option, it is shown as reciprocal relation or inverse relation, so which is not correct. So the one that is not relating to the adsorption process is option D, which is saying that x by m will be equal to P into T. Next we have a question related to the Langmuir adsorption isotherm. The Langmuir adsorption isotherm is deduced using the assumption. So if you look at the Langmuir isotherm, it basically considers that the adsorption happening on a surface is depending upon the available sites, and each and every site will have equivalent ability for binding a particle, and the adsorption of particles at one side will be completely independent of whether the adjacent sites are occupied or not. So this is more like the ideal gas case. If you look at the adsorption of a gas on the surface of a solid, it considers that each and every gas particle would be adsorbing on the surface in a single layer. So it's a monolayer phenomena where the adsorption of the gas will be depending upon the available area, and the adsorption at each and every available site will be equivalent, and the adsorption also will not depend upon whether the adjacent sites are occupied or not. So these are some of the basic assumptions of the Langmuir adsorption isotherm, and the adsorption is explained by this expression where the amount of gas adsorbed will be equal to VL, this is the saturation volume, into P divided by PL plus P. So the PL is basically what we call as the critical desorption pressure. So it is the pressure where we will reach half of the VL value. So the pressure where we will be having half of the VL value, that is what we call as the critical desorption pressure. And we can see at very high pressures, the denominator, the value of PL plus P can be approximated as P, thereby the P will get cancelled, and we'll see that the amount of the gas adsorbed will be nearly becoming equal to the VL, the saturation volume. So this is how the Langmuir adsorption isotherm is explained. And if you look at the options given to us, so we need to pick which of these is the basis of the Langmuir adsorption isotherm. So option A is saying that the adsorption sites are equivalent in their ability to adsorb the particles. Now, this is one of the very fundamental assumptions of the adsorption isotherm that is proposed by Langmuir. So each and every site is equivalent in terms of their ability to absorb the particles. So we can go through the other options as well. Option B is saying that the heat of absorption varies with coverage. No, as we mentioned before, the adsorption is independent of whether the adjacent sites are occupied or not. So the heat of adsorption does not vary with the coverage. And option C is saying that the adsorbed molecules interact with each other. This is also incorrect. As per the theory of Langmuir adsorption isotherm, the molecules which are getting absorbed will be having no interaction with the other molecules. Option D is saying that the adsorption takes place in multi-layers. This is also incorrect. The Langmuir adsorption isotherm theory is a single layer phenomenon. So the one that is the basic assumption of the Langmuir adsorption theory is option A. Next we have a question that is come in multiple years. The plot of log x by m. So here we have to go with the usual nomenclature. So x will refer to the mass of adsorbate, and m will be referring to the mass of the adsorbent, versus log p. So we are looking at the plot between log of x by m versus log p. For the adsorption of a gas on a solid gives a straight line with a slope equal to. So if you look at the Freundlich adsorption isotherm function, x by m will be equal to k into p power 1 by n. So if you take a logarithm on both sides, log of x by m will be equal to log k plus 1 by n into log p. So we are looking at a graph between log of x by m and log p. So if you look at the diagrammatic representation, so whenever they talk about the plot, always the graph will be like, so y versus x. So here the y coordinate will be log of x by m and the x coordinate will be log p. So for this graph, if you look at this function, it is like y is equal to c plus a constant m into x. Here m will be the slope, and the slope value will be 1 by n. And this basically we are deriving based on the Freundlich adsorption isotherm. So the correct answer for this is option D. Which one of the following forms missiles in aqueous solution above certain concentration? So this concentration is what we call as critical missile concentration. So the substance dodecyl trimethyl ammonium chloride, which will have both the non-polar part, which is the hydrophobic part, the organic part, and the polar part, which is the ionic part. So this will be forming missiles, where the non-polar part will be in the center of the missile, and the polar part will be in the peripheral, surrounding by the water molecules. So the substance that will be able to form missiles in aqueous solution above certain concentration, which we call as critical missile concentration, is dodecyl trimethyl ammonium chloride. Next we have a question that has come in the year 2004 related to the enzymes. The enzyme which hydrolyzes triglycerides to fatty acids and glycerol. So the enzyme, we need to find out the enzyme that will be able to hydrolyze triglycerides into fatty acids and glycerol. So if you look at triglycerides, so triglycerides basically will have the structure like this, where on hydrolysis it will give us the fatty acids, long chain carboxylic acids, and glycerol. So glycerol is basically the alcohol with 3 OH groups on adjacent carbons. So the enzyme that will be able to perform this activity is lipase. So the lipase will be able to hydrolyze the triglycerides into fatty acids and glycerol. Now if you look at the other options, we talked about maltase. So maltase basically catalyzes the hydrolysis of maltose into the simple sugar glucose part, and zymase, it will be able to convert sugar into ethanol and carbon dioxide, which will be breaking the sugar into the smaller parts, and pepsin basically breaks down the proteins into smaller amino acids. So the correct enzyme is lipase. Next, we have a question that has come in the year 2003. According to the adsorption theory of catalysis, the speed of reaction increases because, so as per the adsorption theory of catalysis, when the reactant particles come together and adsorb on the surface of solid, so the particles may be coming from the gaseous phase, or they may be coming from the liquid state. So when they are adsorbing on the surface of the solid, adsorption as such is an exothermic phenomenon. So delta H will be negative, and this energy released will actually increase the energy of the particles of reactant, thereby the activation energy value, which is the energy required for the particles to reach the energy level of the intermediate stage, the activation energy value will be decreased. So as the rate constant of every chemical reaction will depend upon the activation energy. So if the activation energy is lowered, rate constant will be increasing, and increase in rate constant will result in speeding up of the chemical reaction. So the adsorption theory of catalysis will justify the speed of chemical reaction based on the lowering of activation energy of the reaction. So the correct answer is option D. We can go through the other options also. So option A is saying that the concentration of reactant molecules at the active centers of the catalyst become high due to adsorption, which is true, but if you look at the overall concentration of the reactant, that will not be changing. Option B is saying that in the process of adsorption, the activation energy of the molecules become large. The activation energy in fact gets reduced, it will not become large. Option C is saying that the adsorption produces heat which increases the speed of the reaction. The adsorption will not be able to directly speed up the reaction by producing heat. It will be able to speed up the reaction by decreasing the activation energy. Next, we have a question that has come in the year 2002. The position of non-polar and polar part in a missile. So if you look at the formation of a missile from the solvated surfactant molecule at low concentration, when the concentration reaches some critical value which we call as critical missile concentration, there will be the formation of the missile, and at the center of the missile we have the non-polar part, whereas the polar part which will be interacting with the water molecules will be at the surface. So we have polar outer surface and non-polar in the inner. So the position of the non-polar and polar parts will be as per this order when missile is being formed. That will be happening only when the concentration is more than the critical missile concentration. Below that, what would happen is all the non-polar part will be projecting outside. So this is the non-polar part, and the polar part will be inside. So this is how below the critical missile concentration, the particles of the electrolyte rather will be staying. Next, we have a question that has come in the year 2001. Which is not correct regarding the adsorption of a gas on the surface of a solid? So we have statements which are given related to the adsorption of a gas on the surface of a solid. Now whenever we have gas particles that are coming and getting adsorbed on the surface of a solid, there are certain considerations and factors on which it depends upon. So we'll go through the options and check which of them is incorrect. So option A is saying that on increasing temperature, adsorption increases continuously. What happens is when we increase the temperature, the particles will obtain more thermal energy, and they would start leaving the surface. As a result of it, if we increase the temperature, the the extent of adsorption value will actually decrease. So the statement that is incorrect is option A. And we can go through the other statements also. Option B is saying that the entropy change is negative. So we have seen in one of the questions that we discussed in the part 1 of the video that for the adsorption, all the three parameters delta G, delta H and delta S, all the three will be negative, because every adsorption is a negative entropy process. From more degree of freedom, a gas or a liquid state, the particles are coming and settling on the surface of the solid, so it will be entropy negative. And since it is spontaneous, it will be del G negative. And if you look at the relation, delta G must be equal to delta H minus T delta S. If delta S is negative, that would mean overall this will be positive. To have del G negative, the only alternative is del H must be negative. So the adsorption should also be a negative enthalpy process. So the adsorptions, whichever type we consider, they will be both negative enthalpy as well as negative entropy. So this is not an incorrect statement, it is a correct statement. Option C is saying that adsorption is more for some specific substances, especially when we talk about the chemisorption or chemical adsorption, then it will be selective in nature. So it will be more for specific types of substances. And option D, so this is also correct. Option D is saying that it is a reversible reaction, which is true. Adsorption can be reversed.